I'm going to find the coordinates of a point on the line y equals 3x plus 1 that is closest to the point 4, 0. Before we get started with this, it's better to actually graph it and see visually what's happening. It's always good to know what it is we're actually doing before we just jump into the algebra. We want to know the whole idea why we're doing this. So the point 4, 0 is going to be right here. I'm going to graph this line y equals 3x plus 1. The slope is 3 over 1. So you start from the y-intercept right here, and we're going to go, top number is positive, we're going to go up 3 and we're going to go 1 to the right. So up 3, 1 to the right would be right here. And then we're going to connect those with a line, and that would be this one right here. Okay. So once we have that, what the question is asking for is what point on this line is going to be the closest distance to this point right here. So that's what we're trying to find. So it's going to be probably somewhere in here, because if I go this way or that way, it's going to be a longer distance. So it's got to be probably something close to about in here. So that gives us an idea at least of what our answer should be. It's going to be less than 1 and a little bit more than 1 for the y value. Okay, so now that we have that, we need to figure out how we need to set up an equation for this one. Okay, now we're talking about a distance here, how far you are away from a line or from 2 points. So because of that, we're going to use the distance formula to help us out on that one. Now the distance formula requires you to have 2 points. So let's write the points down that we have. Of course, the first one is 4, 0, that was given to us. Now the second one would be x and y. But that I'm going to end up with 2 different variables for. So instead of using the y, instead I want to put in an expression for it. Now they tell us that y is equal to 3x plus 1. So instead of the y right here, what I'll do instead is I'm going to write this, 3x plus 1. So now I have my 2 sets of points. Here's my x1, y1, x2, and y2 given here. And I need that because of my distance formula. So distance formula, I'm going to go ahead and write this one up. Again, this came from an earlier section, so we're kind of just reviewing this. So here's the distance formula from a previous section. And what I'm going to do is I'm going to put in the points that I have set up here and put it into the distance formula. Okay, so I get the difference in the x's. I have x minus 4 squared, and then I have 3x plus 1 minus 0 squared. So that would be the setup on it. It's the difference in the x's, these two, difference in the y's. Now that I have this, I need to multiply this out. Remember that you're not allowed to take the square root and cancel out the squares and all that. You're not allowed to do that one. So when you do that, you want to multiply it all out. So it's really x minus 4 times x minus 4. So if you do that, you're going to get x squared minus 8x plus 16. That's what you'll get if you multiply this one out, squaring it out. The other one over here, you're going to do the same thing. You want to multiply that one out. So this is really going to be 3x plus 1 squared, because minus 0, that's going to drop out. So if you multiply that, you're going to get 9x squared. And then you get 3x and 3x, that's 6x. And then plus 1 in the end. So that's what you would get when you multiply and expand all that out. Now I need to simplify inside the square root. So if I simplify inside there, I get 10x squared. I get negative 8 plus 6, that's going to be negative 2x. And I get 16 plus 1 gives 17. So now I have my quadratic inside here. Now there's a rule in the book that says that if you find the minimum of this inside, because we are finding a minimum because we're talking about the word closest to, whatever the minimum of this quadratic is going to be, it's going to be the same for the whole entire thing, including the radical. So therefore, we just need to use the vertex formula with just the part on the inside. We don't have to worry about taking an additional square root of it. We don't need to do that. Whatever we get from negative b over 2a from this formula, that's going to be for the whole thing. So basically the square root we can ignore. Okay, so I'm going to do that over here. I have x is equal to negative b over 2a. That's going to be negative times negative 2. And that's going to be all over 2 times a. In this case, my a is going to be 10. The two negatives cancel out, and the 2's are going to cancel out as well, and that's going to leave you with 1/10. Okay, so that's the x coordinate. Now it's asking us for the coordinates of. So coordinates means we got to find our x and our y value. So here's the x value. The x value is 1/10. We want to find the y value also. So to find that, we're going to put it into this formula, y equals 3x plus 1. That's going to be 3 times 1/10 and then plus 1. If you do 3/10, and this will be 10/10 if you get common denominators, the y value you're going to get is going to be 13/10. So here's our x value, here's our y value. If they want the coordinate, I'll write the answer here. It's going to be 1/10 and 13/10. And if we look at our line that we drew there, that's going to make sense. That point would be about right here. And so then if we draw a line there, that would be, the closest would be perpendicular to that line. If we go anywhere this way or that way, it's going to be too long. So therefore, that would be the closest one, will be a line that's exactly perpendicular to that point. So in doing so, we found out that coordinate, this one right here, has got to be 1/10 and 13/10. That means that this distance would be the closest. It's the closest point to 40.